Today on the Perception in Action podcast, the first episode in a 3-part series looking at the use of virtual environments for training and studying sports skills. What benefits might they bring? How should we design a virtual environment to promote motor learning? And when should we be using it? So it's time for a call to action. Hi everyone. This is Rob Gray from Arizona State University and PerceptionAction.com. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. In today's episode, a look at the ever-growing area of virtual environment use in sports. I wanted to do a series on this topic now because I'm currently immersed, pun intended, in this area while writing up a baseball batting paper and a book chapter on this topic. So I thought I might as well share my thoughts with you while I read and write. In this first episode, I'm going to look at the reasons why many people, myself included, feel that virtual environments can be beneficial for both studying sports and for training them. And I will also discuss what I think should be included in a sports simulation. I'm going to look at both of these issues from a motor learning skill acquisition perspective. Next time, I will evaluate the evidence about whether or not virtual environments are an effective training tool for sports. Is there any evidence of transfer of training? What are some of the important future directions for this area? And finally, in part 3, I'll look at what we've learned about perceptual motor control in sports through the use of virtual environments in research. How can creating impossible situations increase our knowledge about sports performance? Before diving into today's topic, though, I wanted to talk briefly about my own personal history with sports simulation. As I wrote about in a blog that you can find at perceptionaction.com/batsim, I've been messing around with trying to simulate sports, primarily baseball batting, for nearly 20 years now. After I finished my PhD, I felt there was a component to my research that was really missing. I'd spent a lot of time understanding and manipulating the perceptual information that is used in sports, but in my experiments, participants were just responding by pressing a button or turning a knob. In other words, the motor action side of things was completely lacking, and the perception action cycle was really incomplete in my work. But how to solve this? How could I retain precise control over what the person was seeing, but let them respond in a natural way? That is what led me to dive into VR. My first attempt actually involved coming into work on weekends and playing around with a motion tracking system that was part of a driving simulator. I managed to connect it to a Pong video game so that you could move the racket by moving your hand, and I was off and running. Over the years, the motion trackers were attached to a bat, the small circle became a baseball, I added a field in the background, plus auditory and tactile feedback, and the rest is history, I guess. Okay, enough about my story. Let's dive into some background on the use of virtual environments in sports. 'Cause I wanna do the real thing. Oh, I wanna do the real thing. And if we don't do the real thing, I'm not the same. I wanna hear you say yeah. So first off, what exactly is a virtual environment? The typical definition is a collection of technologies which allows a person to interact with a 3D computer-generated model in real time using their natural senses and motor skills. Note here I'm talking about environments which attempt to recreate a specific sport in some way, not generalized training systems like NeuroTracker, which use some of the same technologies. Virtual environments typically have one of 3 functions: entertain, train, or explain. And of course, it's the latter 2 I'm going to be focusing on in this series. The specific technologies involved typically include some sort of projection system, for example, a large screen, a thing called a cave, or a head-mounted display, some sort of motion tracking system, some means for giving haptic or force feedback, and of course the software used to create the environment and alter it according to the user's movements. For a really good review of VR technology as it applies to sports, and some detailed examples, I would highly recommend the review article by Miles and colleagues published in 2012. Link in the show notes. I will return to talking about some of the aspects of VR tech in a second, but first I wanted to address the question, why? In terms of sports training, let's think about some of the evidence-based principles we know from motor learning research that I've been talking about throughout the podcast. For skill acquisition to be effective, we know that you need a large amount of practice that involves a sport-specific context as much as possible, that sufficiently randomizes conditions and varies the environmental constraints, that has the right level of challenge for the particular athlete to promote high levels of autonomy and motivation, that frequently comes close to recreating some of the pressures of real competition, and that provides the right balance of extrinsic and intrinsic feedback. Think about the practical challenges of achieving all of that in real practice. Manipulating constraints and randomizing conditions often requires moving equipment around, or constantly changing settings on something like a pitching machine. This is even more problematic if we have to set the levels of difficulty differently for each player based on their skill. In most practices, there is simply not enough time to do this level of individualized variation sufficiently. It can also be difficult to standardize and repeat conditions. To reliably simulate game context, it will often involve using several players to train only one. For example, to teach a quarterback to read a defense, we need a defense, so you have to get 11 players to train just one. It can be hard to continually create pressure in practice. And finally, in many sports, it's difficult to control the amount of extrinsic feedback. For example, how can we teach a tennis player to become attuned to their body during a serve when they're always seeing where the ball goes? Of course, good coaches have developed clever methods for addressing many of these issues, but using virtual environments can also provide an effective solution. In a virtual sporting environment, it's possible to completely vary the conditions and constraints from one trial to the next. Virtual teammates and opponents can be added easily. The difficulty of the simulation can be easily tailored for the individual, and the amount of extrinsic feedback can be easily controlled. Furthermore, we can augment the environment in some way to enhance performance. For example, using visual cues to direct an athlete's attention to body areas that are most effective for anticipating an opponent's actions. Another advantage a virtual environment can provide is allowing an athlete to get a lot of reps for situations that occur relatively infrequently. A couple good examples of this can be seen from Kathy Craig's work, which we discussed back in the interview we did back in episode 22D. These examples include saving curve free kicks in soccer and responding to deceptive moves in rugby. Another good example could be practicing hitting a knuckleball in baseball. Since they are relatively rare now, a team may not have their own knuckleballer to practice against. And of course, we can now take this even further by simulating a specific opponent to practice against. On the research side of things, a virtual environment can create the opportunity to test hypotheses that could not be assessed using real actions. A good example of this can be seen in research examining catching fly balls. As I discussed way back in episode 5, there are a couple different theories about how this is done that researchers have been debating about for years. Part of the problem in resolving this issue is that for real fly balls, both theories tend to work. One of the key things that an experimenter needs to be able to do is design conditions which create a theoretical dissociation. That is, the two different theories we are comparing make different predictions about what will happen. As discussed in the really nice review article by Frank Zoll and Reinoud Bootsma published in 2011, this has been achieved in virtual environments. For example, it's possible to simulate a ball that flies in a perfect parabolic arc until it reaches its peak height, then it suddenly drops straight down, which of course would never happen to a real ball. I will be talking about this research more in the third episode in the series. I've also used impossible situations a lot in my baseball batting research, including making balls that disappear halfway to the plate, balls that defy gravity, and balls that change their size based on where they're pitched. More on that later. Okay, hopefully I've at least somewhat convinced you about the why. Now let's turn to the question of how. What are the crucial elements of a sporting virtual environment? To answer this question, let's look at two technologies that don't provide many of the benefits proposed for virtual environments: sports video games and videos of sports scenes. A couple of weeks ago, I came across an article, link in the show notes, in which a group of 5 athletes, 3 from the NFL and 2 from the NBA, claimed that playing the popular Madden and NBA 2K video games improved their play on the field. They believed that playing these games had helped them improve their ability to learn defensive schemes, recognize formations, improve their eye-hand coordination, and even execute specific plays like a pick and roll in basketball. To me, this is complete nonsense for several reasons. There are several key differences between real sports and most video game sports that make their usefulness as a training tool highly unlikely. First, the actions involved are completely different. There is no B button in real life, my friends. In real life, we can't execute a complex action like a pick and roll by pulling the right trigger while we hold down the B button. The idea of the coordination required to move a joystick and press a few buttons has any transfer to the coordination needed to perform a crossover dribble or intercept a football is completely ludicrous. A good example of research demonstrating this point was a study of soccer goalkeepers done by Matt Dix, Chris Button, and Keith Davids back in 2010. They examined the gaze behavior and body movements of 8 skilled goalkeepers while they were saving a penalty kick. The critical manipulation was how the keeper responded to the kick. In separate blocks, they had to either move a joystick in the direction of the kick, make a verbal response about where the ball was going, or actually move to save it, as they would in a real game. What was found? When the keeper made a joystick movement or a verbal response, they spent more time looking at the shooter's body than the ball. But when they actually tried to save it, they looked at these two things for roughly an equal amount of time. So in other words, they scanned the visual scene completely differently depending on how they would act. A similar effect was reported in a cricket study by David Mann, Bruce Abernathy, and Damien Farrell in 2010. They found that the way in which expert batters anticipated the direction of a pitch depended on what response they had to perform. Anticipation performance got better when they switched from a passive verbal response to a simple pointing gesture, and better again when they switched from the simple response to an actual swing. The important point made by both of these studies is that how we perceive the world changes depending on how we intend to act on it. That is why it's critical to have a user in a virtual sports training environment be able to act as close as possible to the way they would in real practice. A second important issue here is viewpoint. In most video games, when you play, you view the scene from a third-person, bird's-eye view perspective. This results in the perceptual information used to control one's actions being completely different from what occurs in the real sports. On the one hand, in a video game, the information is allocentric. That is, your position and movement around the playing surface is defined relative to the location of other objects in the environment. So for example, when you're playing quarterback in Madden football, you can see yourself, and in deciding when to throw the ball, you base it on the distance and angle between the avatar of yourself and the avatar of the receiver. In real sports, on the other hand, the information is egocentric. That is, the positions and movements of objects are defined relative to our own body axes, left, right, front, back, and up and down. In real football, there is no visual gap that a quarterback can see between themselves and the receiver because they can't see themselves. Instead, they must use depth and motion cues to time their throw to the receiver. This critically means that the perceptual information used in a video game and in real sports will be completely different, which we know typically results in very little transfer. A related issue to this is that in most video games, the viewpoint is static. So when I turn my head from left to right, the scene in the game doesn't change. This is a problem because it removes some important perceptual information from the optic array. As I've emphasized several times in the podcast, not only do we perceive to act, but we also act to perceive. The fact that our own movements alter the information coming in from our senses allows us to actively get more information when we need it. A good example of this is the depth cue of motion parallax, which I talk about and demonstrate in a recent vlog I posted. Link in the show notes. The final problem I'll mention with video games in terms of training relates to their function. Specifically, They are designed primarily for entertainment, not for training. For this reason, many of the actions and perceptual stimuli are exaggerated. The players can move faster and jump higher, and the sounds are louder, so that again we would expect poor transfer of training. Turning to the use of video for sports training, a lot of the same problems exist. A lot of video footage again involves an allocentric perspective, so the perceptual information is different. Even when an egocentric viewpoint is used for filming, for example in the Striver VR system used by some NFL quarterbacks, which I critiqued back in episode 9b, the viewer can't typically act on the perceptual information, so the perception and action cycle is broken. Even if they can act, for example by mimicking a throw, there is no feedback about the results of their movement because the video can't be altered in response to their movement. We know that this feedback is critical for motor learning and for calibration of actions. Returning to the soccer goalkeeping study by Matt Dix and colleagues I mentioned a few moments ago, they also compared a condition in which a keeper had to move in response to a video of a kicker versus saving a real kick. Again, the video produced gaze behaviors that were completely different than the real situation. The use of video-based systems can be effective when training a very specific aspect of sports. For example, anticipating a tennis serve or recognizing a pitch in baseball. But they do not allow for the full range of training options and keep the sports skill whole like a virtual environment can. Once a performer learns to attune to the information from a video, this perceptual ability still needs to be put back into the perception-action cycle, which can sometimes be difficult and lead to overly hesitant behavior. So, to sum all of that up, for me, there are 3 key critical things we need to have in order to produce a virtual environment that will be effective for training and research. First, we need an egocentric viewpoint that is preferably not static, so that the perceptual information in the simulation matches what occurs in the real sport. Second, the simulation needs to be interactive, such that the user executes the same type of motor actions they do in the real sport, thus keeping the perception-action cycle intact. Finally, the simulation should include accurate multisensory feedback based on the user's movements. So, when I hit a ball, I should see it go out on the field, hear it, and feel it through some sort of haptic vibration. As I've discussed in past episodes, performers do seem to make use of information from their different senses to calibrate their movements. Skilled performers do tend to focus their attention on movement outcomes, and the addition of such feedback can also serve to make a simulation seem more realistic and engaging. There's one aspect of a virtual environment that many believe is critical that I haven't mentioned yet: the use of 3D stereoscopic imagery. How important is this for having an effective sports virtual environment? Well, I think this is still a bit of an open question. On the one hand, having stereoscopic imagery provides important sources of perceptual information for depth and motion that we know are used to control our actions. And 3D can make the simulation seem more realistic and immersive, a point I'll return to in a few moments. However, on the other hand, stereo displays can be extremely expensive, can lead to eye fatigue and discomfort in a user, and often require greater processing demands from the hardware, which can result in visual lags. So, it may not be worth the bother. But anyways, for a really good discussion of the pros and cons of using stereo imagery in virtual reality, I again recommend the review paper by Miles and colleagues. Okay, imagine that we have created a couple different virtual environments for sports that follow all the guidelines I just laid out. How should we evaluate them? Or stated another way, if you're the manager of a sports team, how should you decide whether or not a VR system is worth the investment, and if so, which one to buy? This is an issue that has continually frustrated me over the years, both in sports and the work I've done developing and evaluating flight simulators for the US Air Force. When evaluating a virtual environment, most people focus on completely the wrong things. How realistic do the images look? How many degrees of freedom does the motion platform have? How wide a field of view does the projection system create? How quote-unquote high fidelity is the system? And does the environment create a high degree of presence or immersion? In a training simulation, All of these questions are only relevant to the extent to which they're associated with good transfer of training. They are not important in and of themselves. They are what I would call tangential or secondary criteria. In a training system, the only thing we should care about is training outcomes. If good transfer occurs, then the technical specs are irrelevant. But unfortunately, in my experience, virtual environments and simulations are typically evaluated on a very superficial level. How realistic does the grass look on the playing field? How engaging is the crowd noise? How accurate is the face of the avatar of an opponent? Very few people seem to be asking the right question. How are the design elements of the simulation optimized to achieve transfer of training? If you find yourself in a situation where you are evaluating a system, remember to focus on the key motor learning criteria I talked about at the start of this episode. What is the ability to randomize conditions and constraints? Can we individualize the simulation based on the skill level of the performer in some systematic way? Can it reliably recreate the perceptual information available in the real action and couple it with a realistic response? Is there rich and accurate multisensory feedback that we can control the frequency of in some manner? Does the environment create performance pressure? Can we recreate unusual or even impossible scenarios? Or does the simulation just attempt to perfectly recreate what happens in gameplay? These are the questions you need to be asking. Don't be lured into obsessing over how detailed the signs are on the outfield wall, or the frame rate, or the AI of the avatars. Unfortunately, a major problem in this regard is that we are really completely lacking any research on how these other factors like size of field of view, presence, and fidelity influence transfer of training. Over the years, I've gained some practical intuition about this from working on so many sports, flight, and driving simulators, but I'm also trying to collect some empirical data on this question now. Let's look at a few of these tangential criteria for a training simulation in a bit more detail. First, fidelity. In general, fidelity refers to the extent to which a simulation reproduces the state or behavior of the real-world system. But in practice, it's important to distinguish between two different types: physical fidelity and functional fidelity. Physical fidelity refers to the extent to which the simulation looks, feels, and sounds like the real environment, and this includes perceptual fidelity and motion fidelity. When people use the term high fidelity, this is usually what they're referring to. However, there are really many aspects of physical fidelity that are completely irrelevant for training purposes, so we shouldn't be assessing our sport's virtual environment exclusively based on it. For example, to simulate a baseball stadium with high perceptual fidelity, we should include the sounds of hot dog vendors, simulate the sky accurately, and make sure we have every detail in the texture of the grass. But I think it's safe to say that most of these things will have no effect on transfer of training. What we really want to strive for to achieve transfer is functional fidelity, which refers to the extent to which a virtual environment produces similar behaviors from the user, as in the real environment. Do they use the same perceptual information to control their actions? Have the same gaze behavior? Focus their attention on the same things? Move in the same way? Feel similar levels of pressure? These are the things we need. In my opinion, if we get similar behaviors from the athlete, all the other particulars of the environment are not really that important. What about presence and immersion? These are typically defined as the extent to which the user actually believes they are present in the simulated environment. So we're not talking about just engagement or motivation here. We're talking about tricking our senses and suspending belief about what is going on. Presence and immersion are really kind of elusive concepts that are difficult to study. I would say they fall in the you know it when you see it category. If you've ever been in a VR, for example at an amusement park ride, and have experienced full immersion, you will know it immediately. But it's very hard to measure and quantify. For that and other reasons, there's really no research at all demonstrating a link between the level of presence and transfer of training. But I'll look at this in more detail in the next episode in the series when I go into more detail about research. One last point before leaving the issue of simulator evaluation. How should we be evaluating a sports simulation that is designed for research? Well, here I think physical fidelity is even less important. As I keep trying to emphasize, one of the real advantages to a virtual environment is the ability to break away from being realistic and simulate impossible things. To understand sports skills, it's also critical that we be able to isolate and dissociate different sources of perceptual information. For example, we know that when returning tennis serves, players use advanced cues from the server's kinematics, situational probabilities based on the score, and motion information from the flight of the ball. How important are these different sources of information, and how exactly are they used? Well, that's a difficult question to answer if all these information sources are always present. In a virtual environment, it's possible to selectively remove or change the reliability of one or more of these information sources. This is something that I actually did in a recent baseball batting study I will tell you about in a future episode. Okay, so we've looked at the why and how. An important third question that often gets overlooked is when. I think there are several important points here. At what stage in skill acquisition should we be introducing a virtual environment into training? To a complete novice? Or should we be using it more as a tool for technique refinement or modification in more experienced athletes? It could be argued that the greater novelty and unfamiliar nature of a virtual environment will place an additional attentional load on the capacity of an athlete. Experienced athletes who have developed greater automaticity and have a more external focus of attention might be better equipped to handle these increased attentional demands. Another question is, when should virtual environment training be delivered with respect to real physical training? Should we try to use some sort of periodization plan in which we try to immediately follow virtual training with physical training? As I discussed in my interview with Damien Farrell back in episode 61. To be honest, there is not a lot of work that has been done to help us answer these questions. But I'll return to the issue of when next time. Before wrapping up today's episode, I wanted to address something that everyone might be thinking at this point. Given this immense potential for virtual environments in sports training and research, why haven't they been more widely adopted? Well, I think there are a few different reasons. First, as I've lamented several times on the podcast now, there's just a lack of evidence of transfer of training. Even when we look at an area that has used simulators for decades, like aviation, there's not all that much. This lack of proof is particularly relevant when you look at the cost of many simulators. Using a cave, which typically uses 3D projection systems and presents images on 3 walls, the ceiling, and the floor, can sometimes cost upwards of $250,000. Without a clear return on investment, I understand why many sports teams are hesitant. I think another problem has to do with the design. Overall, designers have been way more focused on realism and fidelity than creating a system that is optimized for training and can be customized for an individual athlete. This has led to a general lack of understanding of what to do with many of the virtual environments that have been developed. But I think these are all solvable issues. We just need more focused research and development. Okay, that's it for today's episode. Hopefully I've piqued your interest about virtual environment usage in sports, and you will return for the next episodes in this series. Next time, I will be evaluating the evidence about the use of virtual environments for sports training. Also remember to check out blog number 7, where I demo how acting can aid perception. You can contact me at robgray@asu.edu or on Twitter at ShakyWeights. And to find out more about the podcast, please check out perceptionaction.com. This is Rob Gray from ASU. Cheers for now.
If tears were liquor